In the previous video, we talked about how to extract attributes, volume attributes, and surface attributes from the original amplitude volume. Right? Those attributes can be quite useful when we do interpretation and if we want to build our structure model later on. But we only talked about the general procedure for extracting any kind of attributes, but we didn't actually look at one attribute in particular in more detail. So now let's look at one specific one very famous attribute. It's called end track attribute. Right. So let's click on the volume attributes and look at how to create the end track attributes. Right. So end tracking is actually underneath the structural methods. Right. So we've got lots of attributes here. If you look at what's actually underneath the structural methods, you've got lots of it, right? 3D curvature, 3D edge enhancement, amplitude and contrast, that kind of thing. And then end tracking is like one of those structural methods for. You can just use end tracking on the original amplitude, volume, right? You can just select the original amplitude volume and then point it in there, and then you do the end tracking on this particular volume, right? The original sort of seismic volume, original seismic amplitude volume. But if you actually move your cursor to the question mark, it's going to tell you the preferred or recommended workflow for doing end tracking. So end tracking is used to extract faults from a pre-processed seismic volume. And then the pre-processing could be variance or chaos combined with structure smoothing. Currently, only realized volume can be calculated. Right. So first thing that you have to sort of realize that if you select the end tracking, then this realized checkbox is going to be checked automatically, right? And it's checked by default. You cannot really change it. So this box is grayed out. So every time you do end tracking, it's going to create a realized volume. So it's going to occupy disk space. It's going to generate a ZGY file. So if you do lots of end tracking, then it's going to create lots of ZGY files, and it's going to occupy lots of disk space. Right. And then the second thing is that it's actually recommending a pre-processing step. And this pre-processing step is called variance or chaos combined with structural smoothing, right? So if you click on this triangle, you're going to see variance, right? It's called edge method, and then structural smoothing. So the recommended workflow is to sort of create a variance volume first, and then do some structural smoothing on that variance volume, and then use that variance volume to actually as the input. Use that smoothed variance volume as the input to the end tracking calculation, right? But let's not do that right now. Later on, we can, if you are interested in trying out this kind of procedure, we can do that, right? It's not really that difficult. It's in terms of procedure, it just takes a few clicks, right? But you'll need to actually try different kinds of settings or parameter settings in order to actually get a really good visualization. And another thing that we want to talk about is the purpose for end tracking, right? So here it's actually telling you for extract faults, right? Extracting faults is actually the major purpose for inventing end tracking, this kind of algorithm. But these days, end tracking can also be used for tracking horizons. If you select the dip angle to be a small, very very small dip angle, then it also allows you to track horizons. If you want to do that, it's if you set the dip angle to a very large value, then it's going to allow you to actually track faults. So depending upon how you're going to use it, you can use it to either track faults or extract horizons. Depends upon the specific application that you are going to look at, right? So let's just for now let's just select the original amplitude seismic volume as the input, and then let's set the output name as end. Right? Just say it's end And then parameters, right? Parameters. It's got lots of parameters, right? It's not like the kind of a RMS amplitude or sort of instantaneous phase, those kind of attributes. It's got just like those attributes has only like one or two parameters. Right? The width of the wing, the wing width is sort of the major parameter. But for the end tracking attribute, you've got like quite a few, right? But let's just look at the first box. Right? If you click on the first box, you got like three different choices: passive, aggressive, and custom. Right. So if you select passive, which means that the ends that's going to be used for tracking the discontinuities are going to be lazy. Those ends are going to be lazy ends. So these kind of lazy ends are going to track just large faults. Those large discontinuities are going to be tracked, right? So passive is going to give you lazy lens. That's going to just track those large scale discontinuities. If you select aggressive, which means those ends that's going to be created are going to be very diligent. They're going to be very diligent ends, and they are going to track not just the large discontinuities, but also small discontinuities. So all those small faults are going to be tracked out, right? So depending upon your preference, if you want to just track those large faults, then you can just set it to passive, right? If you want to extract not just the large faults but also small faults, then aggressive. And then custom is going to allow you to actually specify that's kind of the busyness, the diligentness of the ants that's kind of in between lazy and aggressive, right? So maybe for our first example, let's just try passive, right, and see what's going to be the results, and we can make adjustments based upon the results of the end tracking. If you are just selecting the pre-configured passive or aggressive thing, then the parameters underneath it are going to be automatically adjusted, right? Those are default values for this kind of passive configuration. And then if you select aggressive, then all those grayed out parameters are the default values for the aggressive setting, right? But if you select the custom, then all those slider bars or boxes become configurable. You can select your own values for those different parameters, right? So let's still go back to passive, right? And choose and use those default values. If you are interested in sort of understanding how exactly this algorithm works, you can use those question marks to understand better what's actually the meaning of each of those parameters. And then the next tab is StereoNet. Right? If you click on StereoNet, you're going to see this kind of diagram. The first thing you have to sort of pay attention to is the horizontal and the vertical axis. It's cross line and inline directions. It's not north and east, that kind of direction, right? So the vertical axis is going to be inline direction, and then the horizontal axis is going to be cross line direction. So this kind of StereoNet diagram is configured based upon cross line and inline directions. And if you actually move your cursor to inside of those circles, you're going to see two red numbers, right? Two red numbers are in the lower left corner. One is called dip, the other one is called azimuth, right? So depending upon the position of your cursor inside of this StereoNet, those dip and azimuth are going to have different values, right? The azimuth just means the angle with respect to the inline direction. It's not the angle to the crossline direction or to the north. It's not. It's the azimuth with respect to the inline direction, right? So if I move my cursor to exactly the inline direction, then you're going to see the azimuth is close to 0, right? And as I actually move my cursor and then deviate from the inline direction, the azimuth angle is going to increase. right? So at the crossline direction, it's going to be 90 degrees, more or less, right? More or less about 90 degrees, depending upon the accuracy of my cursor, right? So azimuth just means the angle with respect to the inline direction. And then you also have the dip angle, right? So again, if I move my cursor to this particular, so the azimuth is fixed at 90 degrees, right? But if I move my cursor from the outside of the stereo net towards the interior, towards the center of the stereo net, you're gonna see the dip angle actually decreases, right? So large radius corresponds to large dip angle, and then small radius corresponds to small dip angle, right? So that's what the stereo net actually means. It allows you to specify the kind of a spatial orientation of the discontinuity we are trying to track, right? Um, so um, and then you can sort of see there's a difference between the white color and the gray color, right? Those gray color means that those dip angles and azimuths are blocked out. You don't want the ants to track discontinuities with this kind of a small dip angle and 360 degrees of azimuth. So any discontinuity with a dip angle that's kind of smaller than like 45 degrees, 44 degrees, right? 45 degrees, 45 degrees are not going to be tracked, right? It doesn't matter what's actually the azimuth, as long as the dip angle is smaller than 45 degrees, I'm not going to track it. The ants are not going to track it, right? So it's going to just track those. It's just going to track those discontinuity with a large dip angle, right? So that's sort of the default configuration for tracking faults, basically, right? But if you want to track, not faults but horizons, right? Horizons are like discontinuities with very small dip angles, right? You can reverse the selection. How to actually reverse that selection? You have a button here, but invert the selection of a rejected area. If you click on it, then it's going to give you something like that. So large dip angles are blocked out, but small dip angles like this kind of range are going to be selected, right? But for some reason, it's so if you wanna track those small dip angles, you can just hold down your cursor and drag them. Hold down the left button of your mouse and then drag them across the inner circle to get rid of the gray. Right. So this way, it's going to track those are small dip angles. Discontinue with small angle. If you want to reverse it again, just do this thing, right? And for some reason, it's not sort of doing this kind of thing. Let's block out this. Again, hold down the left button of your cursor and then drag your mouse across this particular circle to actually block out those very small dip angles. Right. If you want to just select a certain kind of azimuth range, suppose you based upon your understanding of the local geology, you know that most of the faults are going to have a strike direction that's kind of a or it's going to have an azimuth that's within this particular range. For example, from within this 45-degree range of inline to crossline, then you can just block out everything. Right? You can just block out everything and then just leave out and then just leave out this quadrant, right? Or you can just click on it. Drag is like, for some reason so if drag is not working for you, you can just click on the water space to block out those regions. So that's going to allow us to just track those discontinuities with a dip angle that's larger than 45 degrees and with an azimuth that's within like 0 to like 45 degrees from the inline, right? This is a way for us to actually specify the range, the dip and azimuth range for tracking those discontinuities. right? And those buttons are just so if you click on this one, it's gonna reset everything. It's gonna reset everything, right? Reset the stereo net to the original default setting. This one is for you to actually reject all sectors for patch visualization. So it's gonna reject everything, right? Uh, and then this one we have used already, right? Invert the selection, and this one is for cycling through deep azimuth resolution options. So for now, the default increment is like 15 degrees. If you want a very fine control, then you can try to densify it. Then the increment is like 10 degrees or something, and then 5 degrees, right? And then 30 degrees, 15 degrees. You can change the increment manually, right? It doesn't have to be those preset values, but the 15 degrees seems to be good enough, I guess. Usually, right? Um, yeah, and that's pretty much all the settings that we need to configure in order to actually extract the end tracking attribute. And after we have finished doing the doing the configuration, we can just click on apply. The thing is that after clicking on the apply, it's going to take a while for the computer to actually extract the end, to do the calculation, to compute the end tracking, right? And then you can watch the progress of the calculation by going to the calculation tab, to the tasks tab. We haven't actually used the task manager yet, right? But it's gonna display the progress of the particular calculation, right? So now let's click on apply, and then right away it's gonna display something in the input pane. It's called end realized, right? But for now, you got a gray cross in front of it, which means that it's not ready for visualization yet, right? And if you go to the task manager, you're gonna see the progress. You're gonna see the progress, right? It's telling you running, and for now it's like 2% is done. So it's gonna take a while for the calculation to complete. Now it's like 7%, right? Because my computer is quite slow, so I'm gonna pause my video here, and after the calculation is done, I will come back. And now the calculation has finished. So if we close this window and then take a look at what's actually the result, turn off the visualization of the original amplitude volume, and then look at the end tracking volume. So it's actually giving us those discontinuities with a quite high angle, right? So at least from what I'm seeing here, it's not tracking the horizon. It's actually tracking the faults more or less, right? And that's the result of the end tracking, right? But the next thing is that how do we actually use the result of the end tracking volume, right? There are two steps that we can do. One is to do manual interpretation based upon this end tracked volume. And another thing is to do this kind of automatic fault extraction. So if we click on the end tracking, end realized one, this particular volume, we're gonna have this seismic tab. It's a context aware tab. Let me turn off the message log so we can see more stuff. And then if we go to this seismic tab, we're gonna see a few buttons that can be applied on this particular volume. One is called fault extraction. It's called automatic fault extraction, right? And then we can use this end tracked volume to actually condition or control the automatic fault extraction process. Right? And then there's a button right next to it This one is going to open a dialog box, but this one is going to allow you to actually pick fault patches, right? So for the extraction, this dialog box is going to create lots of automatically tracked faults, and then you can pick fault patches by using this particular button, right? That's two different procedures for us to actually to do interpretation based upon the end tracking volume. So suppose let's try to find a good inline or cross-line intersection in order to actually do some kind of manual interpretation. If I just drag this one over and see if I can find a good location for doing this. For doing a fault interpretation. It's not. Yeah, maybe. Let's use this. It's not really that good, but nevertheless let's right click on it and then create an interpretation window. And then we can draw our faults on it. At this point, we can just so for my my horizon interpretation, do I have my fault interpretation? If I fault interpretation, this one doesn't actually. Let me just insert a new one into the interpretation folder one. New fault, so a new fault in there, and then we can just start drawing, right? We can just start drawing the fault. Oh, sorry. Button. Just so you can we can do this kind of maybe let's try to insert a new one. Then maybe so this kind of end tracked volume just makes it easier for us to do manual interpretation, right? And depending upon the effect the the particular seismic attributes, that's this particular seismic volume we used to extract the end tracking to do the end tracking on, the result could be quite different, right? For this particular volume, it looks like it's giving us quite clear trends about the locations of the faults in this at least on this particular intersection. So it does make it easier for us to actually manually interpret the faults, right? Just reviewing. So that's doing manual interpretation by using those end tracking volume, right? And then I was showing you there's another button. There's another dialog box that's called fault extraction. Right? If we click on it, then it's going to give us this dialog box. Right? So here you have a blue arrow for us to actually select a particular attribute volume. Here we can just select the end tracked volume and then put it in there, right? And then it's going to do automatic fault extraction using this particular the so-called seismic age volume, right? And in fact, end tracking is just one of those ways for doing for computing seismic age volumes. You also have other ways for doing similar things, but end tracking seems to give you the best effect for the majority of the data. Right. If you want to select the output fault patch names, then you can sort of click on this box and then you can select the name. Let's just use default names. And then so all those parameters can be adjusted, right? If you would like to explore how to use those parameters in the optimal way, you can sort of look into the question marks, move your cursor over the question marks, and find out what's actually the exact meaning of each of the parameters. And once you are done with configuring those parameters, you can just click on this button, extract fault patches. And again, it's going to take a while to actually do the calculations. Let's just click on it, right? So it looks like on my computer, it's progressing pretty quick. It's probably just because we don't have many edges in this particular volume. Oh, it's actually extracting patches one by one, so it's going to take a while. So on the status bar, you can see the progress. On the taskbar, can I see something in the taskbar? Oh, now it's done. I think it's done already. Okay. Let me close this dialog box first. So once it's done with tracking the fault patches, then you're going to see a new folder that's called a fault patch folder. And then end realized one. Let's just display it. So this way it's going to give you a display of all the faults, all the fault patches that has been tracked by this kind of volume, right? Some of the patches are going to be consistent with the manually interpreted faults, but you can sort of see that we have lots of small patches, right? So it's still going to require some kind of manual editing and selecting in order to actually get the correct faults. But you can sort of see the majority of them actually orients in this particular direction, right? So that's probably correct, right? If you look at the so it's actually no, that's incorrect, right? The majority of the faults actually dips in the opposite direction. So for some reason, this the extract faults are sort of dipping in the completely wrong direction. It's probably just because I didn't actually set the parameters correct or something. Probably some of the parameters were completely wrong, I guess, right? But in terms of procedure, that's sort of the procedure for doing. That's sort of the button clicks that's needed in order to do this kind of automatic fault extraction. And if you want to pick fault patches, you can click on it, and then your cursor turns into this kind of crosshair, and then you can sort of pick one. Is it doing anything? Oh, did I? But for some reason, it's not so responsive. Maybe I. And at this point, we have a few options. One is to turn our cursor into the pick mode, and then right click on any of the pages, right? And at this point, we have a few options, right? So convert to faults in fault model. Right? If we click on it, then it's going to allow us to actually just convert this realized faults until convert those automatically tracked fault patches into the structure model that we have created in previous videos. It's called a demo model or something, right? If you have multiple models, it's going to allow you to select which one you want to use, right? And then it's going to convert them into like this kind of a pillar representation of a fault model of the fault patch. It's going to give you a fault model, right? It's going to look something like the stuff that's inside of the fault model, right? Bounding fault, that kind of thing. And another thing is that you can convert them to fault interpretation, right? So suppose you are doing manual fault interpretation already, and then you want to use this kind of automatically created fault patches to augment your manual interpretation. You can just convert those fault patches into fault interpretation, and then later on you can apply the same kind of cleanup procedure to those fault interpretation data, and then do other things. Select the patch. Did I select the right patch? You keep saying that I'm not, so maybe I should just double click on it and then see what I have inside of the operations. Oh, histograms, right? Histograms. So this kind of histograms allows to actually select the fault patches, right? So suppose you move your cursor across a certain portion of the histograms, then it's going to change the fault patches. Right? It's going to allow you to actually filter all the some of the fault patches, I think. It's going to get rid of some of the fault patches. Is it doing anything? Apply. Oh, I forgot. Well, now it's pretty much everything. So now it's going to sort of give you a subset of the fault patches. Right. So this way you can filter out some of the fault patches that's not so reliable. Right. So this is for selecting the fault patches with deep azimuth surface area, for example, right? Lots of them have very small areas, so let's get rid of those. Right. Then that's gonna just leave out the fault patches with large areas. Right. It's even less. So that's sort of the largest fault patches. That's kind of automatically tracked by the hand tracking module. Right. So, and you can also select filter the patches based upon other criteria, right? Patch confidence, that kind of thing, right? You want the ones with the highest confidence. Okay, so it looks like those patches has very high confidence. So that's a pretty good way for us to select the patches, right? And then StereoNet, it's showing us where those patches are located, basically, on the StereoNet, right? So these all those patches actually has azimuth that's kind of close to the inline direction, and then has a dip angle that's like close to like 55 degrees or something, 55 degrees in this kind of range. right? Um, so um, maybe let's just convert them into like let's convert them convert to forcing forward model, right? Let's just do that. Let's put it into a demo model and then click on OK. Oh, I forgot to. So this is actually in the so all the forward patches that we have tracked so far are actually inside of the time domain, right? It's not in the depth domain, but the demo model thing that we have created actually belongs to the belongs to the time domain, right? So that's why it's not allowing us to do that. So let's create a time domain structure model first. Define model. Oh, let's see if I can. So we have to sort of convert the forwards, convert the forward patches tracked by the automatic forward extraction tool to into a structural model, right? But for now, those forward patches are actually in the time domain. So how do we actually convert them into a time domain model, right? So for now, I have a demo model that was constructed in previous videos. This new structural framework thing was not created in the previous videos. It's just something that I was experimenting with. But now we can just right click on the forward patches, right? On end tracked forward patches. Um, so if we actually just select the convert to forward in forward model or convert to forwards in forward model, it's going to tell us that the domain doesn't match. The domain doesn't match, right? Right. Convert to forward in forward model. Source and destination are in different domains. Select the patches you want to convert first, right? So convert to forward. It's basically telling us we are not doing it right. So let's the first thing we're gonna do is to actually to select all the forwards, right? Let's click on this one, select all forward patches, and then you're gonna see that the color of all the forward patches has actually changed, right? So that's giving us some indication about whether those four patches have been selected, right? And then we can just right click again, and then let's use this one, convert to forward in forward model, right? And and then it's actually going to create a new model for us, right? And right away you're going to see that all the forwards now have pillars. That's kind of configured. That's a um, so now if we turn off the visualization of forward patches, we should be able to see all the four pillars. So now inside this new model, later on we can change the name of this model, and then look at all the forward patches, right? So now you have different forwards. You have like 1, 2, 3, 4 different forwards, right? different folds. 1, 2, 3, 4, 4 different folds. And you can sort of turn on the visualization of each one of them and examine their shape and relation to each other. And and at this point, we can start to do Ford model editing. So see if I can. So now you've got those widgets that allows you to actually adjust the shape of those folds actually. And then the rest of the procedure is pretty much the same as before, as what we did when we were working on the structural modeling part. Right? But again, this is still elevation depth. This is meter. It's actually treating the vertical axis as meter, but it's not really meter, right? It's actually milliseconds, but we haven't actually converted all the we haven't actually converted into the depth domain yet, right? So this is actually not the right domain. But we'll deal with that in later videos.